Chapter 2, Section 10 is solving one-step inequalities by multiplying or dividing. And there's a trick here you have to remember. It's that if you're solving an inequality with a negative variable, when you solve it, you're going to have to flip the sign. I'll go over some problems and then I'll try to explain why that is true. But if you saw something like this, negative y is greater than 7, when you solve it, the answer will actually be y is less than negative 7. It sounds weird. Hopefully by the end of this video it makes a little more sense. So I'm just going to work through some problems that are on your packet. Here's number 1. The product of k and negative 5 is no more than 30. So the product of k, so that means I'm multiplying when I see the word product, k and negative 5. So I can write that as k times negative 5, or the way I'd prefer to write it, negative 5 times k. So I've got my coefficient there. Is no more than 30. Is no more than. So it could be 30. If it's no more than 30, then it could possibly be 30. So does that mean, let's see, it's greater than or equal to 30 or less than? Well, if 30 is the top, if 30 is the highest it can be, that means it's got to be less than or equal to 30. So I need to solve this, and solving it is very much like solving any other inequality or any equation. I'm going to divide by negative 5. Since this is negative 5 times k, I want to divide by negative 5. So I can divide by negative 5. And because of balance, since I did something to one side of my equation or inequality sign, I've got to do it to this other side. So negative 5 divided by negative 5 is 1. It's like 1k. And then 30 divided by negative 5 is negative 6, since I've got a positive divided by negative. This 1 is redundant. I don't need it. I mean, I can write 1k, or I can just look at it. There it is, 1 single k. Now, since I had a negative number here, and I divided it out, I actually flipped the sign. So k is greater than or equal to negative 6. So remember that. If you're using a negative variable in an inequality, you have to flip the sign. Number 2, half of p is at least negative 7. So half of p, 1/2 times p is at least negative 7. So at least. So it could be negative 7. So I'm going to have a little equal sign. There's negative 7. And let's see, at least. So that means that the lowest that it can be is negative 7. So half of p is greater than or equal to negative 7. So this is 1/2 times p, which means I can divide by 1/2. So I could write this as divide by 1/2. But one thing you should know is that that instead of dividing by 1/2, I can multiply by the inverse, which would be 2 over 1. So 2 over 1 times 1/2 would equal 2 over 2, which equals 1. I can multiply both sides by 2. So I can just say times 2 and times 2. And my answer would be p is greater than or equal to negative 14, because I had a negative times a positive. Now notice that the sign stayed the same. The sign stayed the same because I did not have a negative coefficient. I didn't have a negative sign in front of this p. So that sign is the same. P is greater than or equal to negative 14. Let's take a look at number 6 here. Negative 5x is less than 10. So there's a negative in front of the variable, which means I'm going to end up flipping the sign. So since this is negative 5 times x, I do the opposite. I divide by negative 5, and I do it to both sides. Negative 5 divided by negative 5 is 1. So I've got my 1x. 10 divided by negative 5 is negative 2. And since there was a negative variable here, negative coefficient in front of the variable, I flip the sign. And once again, you don't need 1x. You can just say x because there it is, one of them. Let's do number 7 first. When I type it out on Microsoft Word, it doesn't look like it looks like on your packet. But on your packet, it's actually x over 4 is greater than 1. Now, since this is x divided by 4, I can multiply by 4, multiply both sides by 4, and then this 4 over 4 is 1. 4 times x over 4. I'm just left with my 1x, and 1 times 4 is 4. So x is greater than 4. Number 8, negative 8 is less than negative 8x. I can flip this right now as long as I keep my, well, we always called it Pac-Man. There I have Pac-Man always eats the larger of the two. Anyways, as long as I keep my sign the way it needs to be, so I've got negative 8x is greater than negative 8. So I just took this whole thing and I flipped it. And I haven't changed any signs yet. I haven't done any solving to change any signs. I just reordered things. So now I can divide by negative 8. Divide by negative 8. And I get x. Negative 8 divided by negative 8 is positive 1 because a negative divided by a negative is a positive. And since I had a negative variable here, I do flip the sign. Since I got rid of that negative, I do have to flip the sign. So now number 11, I thought I would do that one too. This is 1/3 times x is less than negative 6. So 1/3 times x, I could divide by 1/3, but instead I'd rather you know that you can multiply by the inverse. So the inverse would be 3 over 1, or 3, times 3. So 3 over 1 times 1 over 3 is 3 over 3x is less than negative 18. And 3 over 3, 3 divided by 3 is 1. So I could say 1x, or I can just say x is less than negative 18. Okay, so solving an inequality with a negative variable, you flip the sign. The question is why? And this is something that math students worldwide struggle with. Let me see if I can explain it. I'll use this example. Here's my inequality. Y is less than 12. I just chose any inequality. I'm actually using the one in the book. They do a pretty good job explaining it. But here's the inequality. Y is less than 12. I'm going to pick a number for y. It could be 11, 10, 9, 8, 7, 6, 5. But I'll pick 6. Okay, so I'm just going to say one of the numbers that is less than 12 is 6. So let's say I divide by a negative. I'm dividing by a negative, and I'll just pick negative 3. So 6 divided by negative 3 is actually negative 2, and 12 divided by negative 3 is actually negative 4. And negative 2 is greater than negative 4. So notice my sign flipped when I divided by this negative. So what I did here is I used an example. I changed a variable, replaced it with a real number to prove that this is true. When I divide by a negative, I must flip the sign. And here's, I drew a little line here so you can see on a number line, if I had 0 here, 6 would probably be there, and there would be 12. So we can see that 12 is greater than 6. But if I divide by a negative here like I did, negative 2 would be right there, and negative 4 would be there. So 2 is greater than negative 4. I'll use this example also. Once again, my inequality. Y has got to be something less than 12. So I'll choose 6 again. 6 will be the number that is definitely less than 12. Now if I multiply by a positive number, oops, what am I saying? If I multiply by a negative, 6 times negative 2 is negative 12. But 12 times negative 2 is negative 24. Negative 12 is actually greater than negative 24 because it's closer to 0. When we talk greater than and less than, a number is greater than another number if it's farther to the right on a number line. So notice again, the sign flips. Even though in my original inequality, y was less than 12, so I chose 6. If I multiply those by negatives, the sign does flip because this negative 12 is greater than negative 24. If you're saying, what? That's okay. If you're saying, I don't get it, that's okay. Just remember the rule. If you have a negative variable in an inequality, you're going to have to flip the inequality sign when you solve it.